Bismillahir Rahmanir Rahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to solve some more questions for International A-Level Edexcel Mechanics M1. The topic is vectors in mechanics, and we are actually solving the past paper handout. So the past paper handout for chapter number 3, that is vectors in mechanics. I've made some videos earlier as well. You can find the playlist in the description of this video, so you can access all of the videos from one link. Okay, and here we have handout question number 6, which is GCE M1 June 2012, question number 6. So let's see what the question says. A ship S is moving with constant velocity minus 12 I plus 7.5 j kilometer per hour. This is the constant velocity vector, and the requirement of part A is to find the direction in which the ship S is moving, and we need to give our answer as a bearing. So what we know, the fact is that the velocity vector tells us the direction of the motion of the particle. Okay, so velocity vector tells you in which direction you are going. All right, so what's happening is that the constant velocity vector is minus 12I plus 7.5 j. So this is basically the starting point, let's say, and you are going 12 units towards left. Okay, so minus 12y, and you are going 7.5 j upwards. Okay, so this is basically the velocity vector over here, and we need to find the bearing. So we are going to make a north on the starting point, and the bearing is measured in clockwise direction. So we need to find this reflex angle, which is obviously more than 270 degrees over here. Okay, so I'm going to mark this acute angle as theta. Okay, so in order to find this acute angle theta, I can say that tan theta is equals to opposite over adjacent, meaning 7.5 divided by 12. Okay, so our answer as a bearing would be like 270 plus theta. Okay, and theta is basically tan inverse 7.5 divided by 12. As simple as that. So 270 degrees plus, what is the value of tan inverse? 7.5 divided by 12. So the value is 32.01 degrees. Okay. So 270 plus 32.01 degrees. So 270 plus theta, this will give you 302.01. Okay. So the bearing is 302 degrees. All right. So therefore, the bearing is 302 degrees. This is supposed to be your answer. Alternatively, what you can also do is you can find this angle as well. If I mark this angle x, so the bearing would be 360 minus x. And this angle x, you can find it by that way, that opposite side would be 12 and adjacent would be 7.5. So 360 minus tan inverse 12 divided by 7.5. This will also give you the same value. Okay, you can just check it. 360 minus tan inverse 12 divided by 7.5. This will also give you the same value, and the bearing is 302 degrees. So here was a requirement for part A. So now let's move on to the next part. At time t hours after noon, at time t hours after noon, the position vector of S is small s kilometer. When t is equal to 0, small s vector is 40I minus 6j, meaning the initial position vector. This s will act as the initial position vector r naught. Okay, so we need to express s in terms of t. Okay, we just simply need to state the vector over here. So the concept is that the position vector is r is equals to r naught plus vt. Okay, so the initial position vector is basically given to us 40I minus 6j. Okay, and we need to express this s vector. So small s is replaced with r, and r naught is basically 40I minus 6j, and the constant velocity vector, since we are dealing with constant velocity, so r is equals to r naught plus vt. Conceptually, this is r is equals to r naught plus the displacement vector. But in the case of constant velocity, the displacement is velocity multiplied by t. So in the case of constant velocity, we use r is equals to r naught plus vt. Okay, so the constant velocity vector is given to us in the question, which is minus 12y plus 7.5j. So we are going to put it over here. Okay, if you leave your answer in this form, that is perfectly fine. No worries with that. You are going to get your full 2 marks over here. But you can perform one more step, which is quite helpful for the further parts. I've discussed this thing in my earlier videos as well, that taking I as common multiplied by 40 minus 12t. Okay, and then taking j as common multiplied by minus 6 plus 7.5t. This step is quite helpful for the further parts. So my usual way is to express the answer finally in this form. Okay. Now coming on to part C. Part C is saying that a fixed beacon B is at the point with position vector 7i plus 12.5. Okay, this is a fixed beacon B, meaning this is a fixed point B, meaning this is the position vector of point B, which is the OB vector. Okay, we need to find the distance of the ship from B when t is equals to 3. Wonderful. So as simple as that, what we know the fact is that, since we have found the position vector of ship at any value of t, so this is basically the OS vector. Okay, so what I'm going to do through vector subtraction law, I'm going to find the displacement vector SP, or you can say BS. Okay, and once I'm able to find that vector BS, so I can substitute t is equals to 3 and get the displacement vector, and then I will find the magnitude of that vector, which will give me the distance. Okay, so I'm going to bring the picture of this question on the next page so we can have more space for working. All right, so for part C, I'm going to find the BS vector, or you can say simply SB vector. That's perfectly fine. So according to vector subtraction law, BS would be OS minus OB. The vector subtraction law you are studying since O level and IGCSE mathematics. Okay, so the OS vector is I component is 40 minus 12t. Okay, so you can do your working in the column vector form. That's perfectly fine. And the J component is minus 6 plus 7.5t, or you can say 7.5t minus 6. And then subtract the OB vector. Okay, OB vector is the position vector of point B. Okay, which is I component is 7 and J component is 12.5. So I'm going to find this BS vector in terms of t. So 40 minus 12t minus 7, meaning 33 minus 12t is the I component, and then 7.5t minus 6 minus 12.5, so 7.5t minus 6 minus 12.5, this will be minus 18.5. Okay, so this is basically the BS vector. And now I'm going to substitute t is equals to 3 over here, and I'm going to obtain the BS vector in the form of I and j. Okay, where the I component will be known and j component will also be known. So BS vector at t is equals to 3, this is supposed to be 33 minus 12 times 3 and 7.53 minus 18.5. So 33 minus 12 times 3, the I component is minus 3 and the j component will be 7.5 times 3 minus 18.5. This is supposed to be 4. So minus 3i plus 4j kilometer. This is the BS vector. And now I'm going to find the magnitude of this BS vector. Okay, so under root of minus 3 whole squared plus 4 squared. All right. Under root of minus 3 whole squared plus 4 square, which means under root of 9 plus 16, which is under root of 25, which is 5 kilometer. This is the distance of S from B when t is equals to 3. This is supposed to be your answer to part C. All right. So now let's move on to the next part. Part D is saying that find the distance of the ship S from B when S is due north of B. So the thing is that the ship is due north of point B, and as you know that point B is a fixed point and ship is due north of point B, meaning ship is vertically upwards from point B. Okay, so for that purpose I am going to solve this part D over here. Okay, so ship is due north of point B. Point B is a fixed point and ship is vertically upwards from point B. So if we make a north at point B, so this is how the scenario is going on over here. Okay, so obviously we would need to find a value of t over here. And once we are able to find the value of t, at that particular instant, at that value of t, we are going to find the BS vector in terms of I and j. And once you are able to find the displacement vector BS in terms of I and j, then you will find the magnitude and then you would be able to get the required distance. Okay, so as you already know that we have obtained the BS vector in terms of I and j, which is 33 minus 12t. This is the I component, and 7.5t minus 18.5. This is the j component. Okay, so when you know you are going from point B till point S, okay, so the I component is not changing, right? We can say that the I component of BS vector is equal to 0 because we would have a vertical distance, right? Because there is no change in the I components when you are going from B to S. Or you can just simply say that, you know, the I component of the OS vector and the I component of OB vector are the same. So it is exactly the same thing as saying that, you know, the I component of the BS vector is equal to 0. Okay, so I can say that I component I component of BS vector is equal to 0. Make sense or not? Okay, so this 33 minus 12t will be equated with 0. So the value of t will be 33 divided by 12. So 33 divided by 12 is 11 over 4, which is 2.75. So t is equals to 11 over 4. All right. And now what we are going to do, we are going to put it in the j component, because as we know that I component will be 0 and we need to find the distance, right? And the distance would be the vertical distance, meaning whatever the j component of BS vector is, that will be the required distance. Makes sense? Because ship is due north of point B. All right. Whatever the j component value will be for this BS vector, that will be the required distance, which is the vertical distance over here. So just substitute this value of t into the j component. So 7.5 times 11 over 4 minus 18.5. Okay, let me सही से लिख दूं. All right, so we have substituted t is equal to 11 over 4 into the j component. So 7.5 multiplied by 11 over 4 minus 18.5. This is 17 over 8. 17 over 8 kilometers, or you can say 2.125 kilometer. This is supposed to be your answer, the required distance. So the BS vector is actually, the I component is 0 when we substitute t is equals to 11 over 4, and the j component is 17 over 8. So you don't need to, perform this very basic step that we are finding the magnitude of BS vector like this, that under root of 0 square plus 17 over 8 squared, then effect of under root and square will cancel out and 17 over 8 will be your answer. This is not required. Okay, this thing is enough. It would be sufficient. As you already know that, ship is due north of B. So you just need to communicate the whole scenario to the examiner that what is the meaning of finding the distance of ship from B when ship is due north of B? You have already explained this thing enough. Okay, the I component of BS vector is equal to 0. You have just equated it. So this is enough piece of evidence that you already know the concept behind this. Okay, so finding the J component would be just sufficient, and 17 over 8 kilometer, or you can simply say 2.125 kilometer is your answer. Okay, so this was the question number 6 of handout, which is GCE M1 June 2012, question number 6. So now let's move on to the next question. So now up next is question number 7 of the handout, which is GCE M1 January 2013, question number 6. All right. So the question says that a ship sets sail at 9 a.m. from a port P and moves with constant velocity. The position vector of ship P is 4i minus 8j kilometer. At 9:30 a.m., the ship is at the point with the position vector I minus 4j kilometer. So requirement of part A is to find the speed of the ship in kilometer per hour. Okay, so basically at 9 a.m. the journey is starting. Okay, and time is basically in hours. All right, so this means that at 9:30 a.m. t will be equals to half. So we need to first find the velocity of the ship in kilometer per hour, and then we will find the magnitude so that we get the required speed. So the ship is moving with constant velocity. Okay, so I'm going to say that r is equals to r naught plus vt. Okay, so the initial position vector of the ship is basically 4i minus 8j kilometer. All right, so r naught vector is 4i minus 8j. This is the r naught vector, and the constant velocity vector is, you know, we don't know. Okay, the constant velocity vector we don't know. We need to find the constant velocity vector, so v is unknown. And at 9:30 a.m., meaning at t is equals to half, at t is equals to half hours, okay, the position vector is I minus 4j kilometer. Okay, so at t is equals to half, the position vector is I minus 4j kilometer. Okay, so through this we are going to find the constant velocity vector. So I'm going to say that half v is equals to I minus 4i minus 4j plus 8j. Okay, so half v is equals to minus 3i plus 4j. So v will be equals to 2 is completely multiplied by minus 3i plus 4j. Therefore, the constant velocity vector is minus 6i plus 8j kilometer per hour. And what we need to do, we just need to find the magnitude so we can tell the speed. So the magnitude of the velocity vector is basically under root of minus 6 whole squared plus 8 squared. So under root of 36 plus 64, meaning under root of 100, which is 10 kilometer per hour. This is the required speed which you need to find. As simple as that. So now in part B, show that the position vector r kilometer of the ship t hours after 9 a.m. is given by this. R is equals to the I component is 4 minus 60 and the j component is 8t minus 8. We need to show the vector in this specific form. So as we have found the constant velocity vector, so for part B, r is equals to r naught plus vt. So we are going to use the constant velocity vector. R naught was 4i minus 8j, as we have seen in the information in the question. Okay, and the constant velocity vector we have found in part A, which is minus 6i plus 8j, and t is unknown. Okay, so now I can say that taking I is common, multiplied by 4 minus 60, okay, and then taking j as common, multiplied by minus 8 plus 8t. So is this the required form? Yes, it is. I mean, just one more step. You write it exactly like this, that j component is 8t minus 8. So r is equals to 4 minus 6t. This is the I component, and 8t minus 8 is the j component. This is supposed to be your answer. So now let's move on to part C. Okay, and for that purpose, I'll bring the question on the next page. Okay, so for part C, the information is that at 10 a.m., meaning, when your journey is starting at 9 a.m., so when you are saying that at 10 a.m., this means t is equals to 1. T is equals to 1 hour. So at t is equals to 1, a passenger on the ship observes that a lighthouse L is due west of the ship, and at 10:30 a.m., meaning t is equals to 1.5 hours. Makes sense? At t is equals to 1.5 hours, the passenger observes that the lighthouse L is now southwest of the ship. Southwest means halfway between south and west. Okay, exactly between south and west. Okay, so this is the way of saying halfway between south and west. So the requirement of part C is to find the position vector of the lighthouse, L. So first thing first, before attempting this part, first of all, I'm going to make a sketch over here to tell you what's actually going on over here. Okay, so if you make an axis, all right, so the initial position vector is 4i minus 8j. Okay, so 4 comma minus 8 is the initial point. Let's say somewhere over here. Okay, 4i minus 8j. Here I'll mark this as the initial position vector. This is the r naught. So 4i minus 8j means 4 comma minus 8. And the ship is going with constant velocity of how much? Constant velocity vector is minus 6i plus 8j. Okay, so the path of ship is going like this. 6i, what? The I component is minus 6 and j component is positive 8. Okay, so minus 6 towards the left and 8 above. Okay, in this path. In this path, basically the ship is going. Alright, so I'm going to make a path like this. The ship is actually traveling in this path. Okay, you need to understand this thing. So what we can do, first of all, as we have already established the fact that at 10 a.m. t is equals to 1. So at t is equals to 1, I can find the position vector of the ship. Okay, since we have found the position vector in terms of t, isn't it? 4 minus 6t is the I component. Okay, we have shown this in part B. I can just see the expression over here. So I'm going to say that at 10 a.m. the position vector of the ship is 4 minus 6 times 1. This is the I component. Okay, and the j component is 8 times 1 minus 8. Okay, so 4 minus 6 is minus 2. So minus 2i, and the j component is 0 because 8 minus 8 is 0. So at t is equals to 1, the position vector of the ship is minus 2i. Meaning at t is equals to 1, the ship is on the horizontal axis over here. This makes sense in your head. I can say that at t is equals to 1, the ship is over here, and this is basically the point minus 2 comma 0. Okay, because the position vector is minus 2i, as simple as that. And when we are talking about 10:30 a.m., so at 9 a.m. our journey started. So at 10:30 a.m. t is equals to 1.5 hours. I can say that, when we are talking about 10:30 a.m., so 10:30 a.m. is like saying that t is equals to 1.5 hours. Okay, so what I'm going to do is I'm going to put t is equals to 1.5 in the expression. So 4 minus 6 times 1.5, this is the I component, and 8 times 1.5, minus 8, this is the j component. Okay, so 4 minus 6 times 1.5, this is minus 5. Okay, so minus 5i, and 8 times 1.5 minus 8, this is 4j. So minus 5i plus 4j, this is the position vector of the ship at t is equals to 1.5 hours. Okay, so at t is equals to 1.5, the ship is, somewhere over here. This is the point minus 5 comma 4, because I component is minus 5 and j component is 4. Okay, since we are, as you know that the position vector is basically related with the origin, right? So we are comparing it with the origin. So the coordinates, I have just mentioned the coordinates over here for your ease. Okay, so at t is equals to 1, the coordinates are minus 2 comma 0, and at t is equals to 1.5, the coordinates of the ship are minus 5 comma 4. So far we have achieved this much. So basically the question arises, where is the lighthouse? The question arises in a sane mind, where is the lighthouse? Okay, so I'm just going to, take a screenshot of this picture and enlarge this and bring it down so I can give some more illustrations over there. Okay, this would be better to enlarge the picture over here. This looks fine. All right, so when t was equals to 1, the passenger on the ship, basically this is the path of the ship. Okay, ship is going in this path, and let's say you are on the ship, you are the passenger who is on the ship. Okay, so when t is equals to 1, the passenger sees that the lighthouse is due west of the ship. All right, so as you know that compass, north, south, east and west. East is on the right and west is on the left. So at t is equals to 1, let's say you are the passenger on the ship and you observe that the lighthouse is on the left hand side. It is due west. Okay, so I'm going to say that the point L, which is basically the position vector of the lighthouse, it is somewhere over here. Okay, I don't know the exact location right now because we are talking up till t is equals to 1. What I know the fact is that that point L is somewhere over here on the left on the horizontal axis. Okay, because the point L would be a fixed point. The position vector of the lighthouse will be a fixed point. It cannot change over the period of time, right? It cannot change over the period of time. What can actually change over the period of time is the position of the ship. And you are the passenger on the ship, so your position vector is going to change according to the change in time. Because when t is equals to 1, you are over here, and at t is equals to 1.5, you are over here. Okay, so first thing we have established that the lighthouse L is on the left hand side of this point t is equals to 1, meaning on the left hand side of minus 2 comma 0. What is the exact location? We don't know right now unless we read the other information. Okay, so this essentially means that the position vector of the lighthouse is on the horizontal axis, meaning the j component is 0. From this statement, from the information that at t is equals to 1, a passenger on the ship observes that a lighthouse L is due west of the ship. From this statement, I can establish the fact that, you know, the j component of L, meaning the j component of the position vector of the lighthouse is 0. This is a established fact now. Okay. All right. And then in the very next information, at 10:30 a.m., meaning at t is equals to 1.5 hours, the passenger observes that the point L is now southwest of the ship. So at t is equals to 1.5, the ship is over here. At t is equals to 1.5, the ship is over here, and the passenger sees that, the lighthouse L is southwest of ship, meaning halfway between south and west. So the compass is like this, right? South is downwards and west is on the left. So halfway between south and west. Wonderful. So I'm going to extend this horizontal axis over here. Okay. So Here is basically the lighthouse. This is a fixed point of the lighthouse. Okay, southwest means halfway between south and west. Okay, southwest essentially means halfway, halfway between south and west. Okay, at exactly the midpoint of south and west, that is the line. Okay, so anyone would say that this line is basically an upward sloping line. An upward sloping line would have a gradient of a positive value, right? The gradient would be positive and the gradient will be 1. I have explained this concept in detail in my previous video as well. You can access the link from the description of this video. You can access the playlist. Okay, and in my previous video, I have, you know, explained the concept in detail over there. All right, when we consider the gradient approach. So what I'm trying to tell you is that southwest means halfway between south and west. This means that, south and west are perpendicular to each other. So the half of that angle, this will be a 45-degree angle. When this is the 45-degree angle over here, so, this angle is also the same thing, according to alternate angles property. This angle from the positive horizontal axis is also 45 degrees. All right. So this is basically the whole idea. So what I can do is I can find this LS vector. Okay, even if I find this SL vector, that is also perfectly fine. But anyone would see this line, they would say, oh, this is an upward sloping line, isn't it? An upward sloping line will have a positive gradient. And as we know that, when we are having a connection between the gradient and the angle from the positive horizontal axis. So the formula is gradient is equals to tan theta, m is equals to tan theta. So m is equals to tan 45 degrees. I've explained this concept as well in my previous video. Okay, so you can see that video as well. Okay, if you are not clear with this concept. So the gradient of this upward sloping line will be 1. So I'm going to find this LS vector over here. Okay, and the gradient of this line is basically 1, and I'm going to find the LS vector. And we have already known that this point is minus 2 comma 0 and this point is minus 5 comma 4. Okay, and what we also know that you know this point L is basically on the horizontal axis. So let's say this point L, the position vector of the lighthouse, is, let's say, a comma 0. Okay, where a is unknown right now. All right, so what I can say is that the line which is connecting these 2 points, because that the approach is quite simple in this question because we know the coordinates. So I can just say that the gradient of this upward sloping line is 1. Okay, so we can say that the gradient of the line which is connecting these 2 points, one point is a comma 0 and the other one is minus 5 comma 4. Okay, this point t is equals to 1.5. At t is equals to 1.5, this point is minus 5 comma 4. Minus 5 comma 4. Let me remove that black line. Okay, so the gradient of the line which is connecting these 2 points is positive 1. Okay, so m is equals to 1. So I can say that y2 minus y1 over x2 minus x1 is equals to 1. So 4 minus 0 divided by minus 5 minus a is equals to 1. So 4 is equals to minus 5 minus a, meaning a is equals to minus 5 minus 4. So a is minus 9. And therefore, we have established the fact that the position vector of the lighthouse is minus 9i. Okay, therefore the position vector of point L, the lighthouse, is minus 9i. This is supposed to be your required answer. As simple as that. Okay, so when t is equals to 1, we already established that the lighthouse L is on the horizontal axis. We already established that the j component of the lighthouse L is 0. Okay, so each and every information over here is very helpful. All right, so this was, the complete solution for this part C, and I hope I have given detailed enough explanation. All right, so this is basically the whole idea behind this. All right, so we established that, this angle is 45 degrees, so gradient of this upward sloping line is 1. And what else you can say is that when you are making a compass on this point at t is equals to 1.5, meaning minus 5 comma 4. Okay, so halfway between south and west means that angle from the positive horizontal axis is 180 plus 45 degrees, which is 225 degrees. Okay, and 225 degrees is basically the angle in the third quadrant, and tan theta is positive in the third quadrant. So tan 225 is also equals to 1. You can also find the gradient in this way. All right. So this is basically how you approach these type of questions. So this was basically question number 7 of the handout, which is January 2013, question number 6. Okay. So I'll be making more videos, inshallah, very soon. So stay tuned to my channel. Thanks for watching. Assalamu alaikum.